Yes?
Yes, sir.
Okay. So this is the first lecture on logic. So I start with the definition of proposition. So in this lecture, we will see lots of definitions only. So obviously you have to remember those definitions because in this syllabus that you have that logic part, and here you have to remember the definitions only. And if you remember the definitions, then that the examples and the problems will be very trivial to you. So you will understand that this portion is very trivial. So what is a proposition? So a proposition is a declarative sentence that is either true or false, but not both. So I can write. So a proposition is a declarative sentence that is either true or false, but not both. That's when it can be true or false, but cannot be both. Okay. Now, what do you mean by that declarative sentence? So that's mean this is means a sentence which declares a fact. Okay. So we will see some examples. So then it will be clear to you. First, I will write few sentences. Okay. So first I will write few sentences and then we will decide, or so we will discuss which are the proposition and which are not. Okay. So first example is we can write that say New Delhi is the capital of India. Okay. Now tell me, is it a proposition? See, what is a proposition? This is a declarative sentence. That's mean a sentence which declares a fact, right? And here New Delhi is the capital of India. So this is a declarative sentence because this sentence declares a fact, right? And also this is true. So this is a proposition. And this proposition is also true. A proposition can be false as well, right? Now say the next one. Example. If I write 1 plus 1 equal to 2. Now again, 1 plus 1 equal to 2. Now again, this is a fact, right? So this sentence declares a fact. So therefore, again, it is a proposition. Okay? And this proposition is true, right? Now if I write 1 plus 2 equal to 4. Now tell me, is this a proposition? Yes or no?
Yes.
Yes, sir.
Yes. This
Yes.
is a proposition and the truth value is it is false, right? So this is a false statement. So this is a proposition, but this is false. Okay. Now if I write, say, what time is it? This one. Now is this a proposition?
No, sir.
No, sir.
No, because it is not declaring any fact, right? This is just a question. So this is not a proposition. So if I say that read this carefully. Now again, now this is a order, right? So this is an order. Again, this is not declaring any fact, right? So again, this is not a proposition. Now what if I write that x plus 1 equal to 2? Now is this a proposition?
No.
No, sir.
Again,
No, sir.
this again no, right? Because this is declaring a fact. That is fine, that x plus 1 equal to 2. But the problem is that we cannot say that it is true or false, because it is totally depending on x. We do not know what is x, right? So this is a declarative sentence, but we cannot determine it is true or false, right? So therefore this is not a proposition. Okay. Oops. Okay, fine. Now the next definition is negation. So first of all, we know what is a proposition. So now let P be a proposition. So from now onward, if we use that P, Q, R, so we will write this as a proposition. That's when P is a declarative sentence, okay, which is either true or false. That's when it should have a truth value. Now let P be a proposition. That's mean P is a declarative sentence which has a truth value, that is either true or false. Then the negation of P, and it is denoted by that minus P or P bar. Now during this course I use that minus P. Okay, so I do not like P bar, but it is right. I have written here minus P, but we will read this is as a not P. Okay, so we will not say that it is minus P. We will say that it is not P. Okay, so let P be a proposition. The negation of P denoted by not P is the statement is it is not the case that P. Okay, so P is a statement and not P is a statement that it is not the case that P. Okay, so I will give one examples to understand this fact. What do you mean by it is not the case that P? So for an example, so suppose P is the statement say my smartphone has at least 32 GB of memory. Okay, so this is P. Then the negation of P is, so there are many ways to express the negation. The fast straightforward is this one. It is not the case that P. Okay, but this is a kind of cheating because we generally do not say in this way, right? But anyway, first we write that. So the negation is, it is not the case that my smartphone has at least 32 GB of memory. Okay, so this is the negation, straightforward negation. But generally, when we ask, so write the negation, you should not write this one. So actually, we don't want this. Okay, but this is correct. So this is a correct statement, but we do not want this one. So we want negation of P in a simple sentence. Okay. So if you simplify this sentence, so you can write that first of all, my smartphone so does not have at least 32 GB of memory. Okay, so both this and this are equivalent, right? And we can simplify this as well. So we can write in more simply, we can write it is my smartphone has less than 32 GB of memory. Okay, so you can say that the negation of this is this one. So during the exam, if suppose if we ask or if you are asked that find a negation of a statement, then you should write either this or this. You should not write this because otherwise there will be no meaning of a finding negation, right? Because for any statement you can just add that it is not the case that that, but that does not look good, right? So you should write the negation in a simple sentence like this. Okay. So though these statements look straightforward, but finding negation of a statement is not always straightforward. In the next lecture, we will see some statements, and it will be difficult to find a negation of that statement. But obviously, that is difficult in the sense that not straightforward. Okay, but obviously you can find that. Okay, but just a confirmation. So can you hear me? Or yes?
Yes, sir.
Okay, okay,
Yes, sir.
fine, fine, fine. Okay. So I got no chance, so I thought, okay, maybe I am not audible again. Right. Now, generally, we express all of this logic portion in terms of truth table. So what is a truth table? So we just write true or false for a statement, and we will find the true or false or the other statements. For an example, the truth table for the negation of a proposition P is, so we write in this way. So this is P, this is not P. Okay. Now if P is true, then its negation will be false. And if P is false, its negation will be true. So this is called the truth table. Okay. So similarly, we define some more terms. So now it got this is negation, and then we will define conjunction. So this is just AND one. So AND of two statement. So in terms of logic, we call it is conjunction. Okay, so I am just writing from the book. So I will not provide any lecture notes. You just go through that book. So definitely you will get everything there. Okay, so I'm writing from that one only. So let P and Q be two propositions. Okay, then the conjunction of P and Q, this is denoted by P by this symbol, that's been P and Q, and is the proposition P and Q. Okay, and the truth table, so you can easily construct a truth table here. So the truth table for the conjunction of two propositions P and Q is, see here we have two sentences, right? So we need four row, that is true, false, that is P true, Q true, P true, Q false, P false, Q true, and P false, Q false. So we need four row. So this is P, this is Q, and this is P and Q. Okay. Now if P and Q both are true, then their AND, that is P and Q both should be true. So that is true and true. If you take that conjunction, that will be true. Okay. Now if P is true, Q is false, then if you put that AND statement, then that statement is not true. That's mean that is false, right? So if you have a true statement and a false statement, so they are combining. If you choose that AND one, then that will be a false statement, right? So that will be false. Similarly, if you take false and true, that will be false. And if you have two false statement, that will be false. So this is the truth table for the conjunction. Okay. Now similarly, you can make the truth table for the disjunction as well. Now what is disjunction? So it is and now we will have the another operation, that is or, P or Q. And in the terms of logic, that is in terms of logic language, we call it as disjunction. So let P and Q be two propositions. Then the disjunction of P and Q, it is denoted by, it is P or Q. Okay, so we will read as P or Q, and is the proposition P or Q. So that's when you have two proposition P and Q, and the disjunction is they are combining that two propositions by or. Okay. And similarly, you can find a truth table. So the truth table for the disjunction of two propositions P and Q is this one. So again, we need 4 row. Okay. So this is P, this is Q, this is P or Q. Okay. Now if P is true, Q is true, then P or Q, that is true. Now if P is true, Q is false. Now the statement P or Q. So you have already P is true. So therefore P or Q will be true. Similarly, false and true. So if P is false and Q is true, then P or Q will be true. And both, if both are false, then they're combining, that is P or Q will be false, right? So this is just the difference between conjunction and disjunction. So here we have one true. So this is true if and only if you have both P and Q are true. Okay. And here this will be false if and only both are false. Otherwise the value will be true. Okay. So simple one. Now there are some more terms like this. So why we are defining these terms, that conjunction, disjunction, negation. So then after that you can just play with all of these uh, logic operations, right? So you can choose any proposition, say P, Q, R, you just apply these logic operations and you can find out which are equivalent, which are not. You can find a truth table, right? You can just play with all of this. Okay. So now we define that exclusive OR. So this is not very useful. So this name is exclusive OR. So though it is not very useful, but since it is a logic operation, we are defining this. Okay. But obviously, if you want to find some truth table for some complicated logic operations, you can use this. So you can play with this one as well. So again, we start with P and Q. So this be two propositions. Okay. Now the exclusive OR of P and Q. Now this is denoted by. You should remember that notations as well. So generally that it is direction kind of notations we use for this exclusive OR. Also this is so you should use these notations, but this notations is not standard always. That's mean different book may use different notations. Okay. But if you use a different notations, then it will be difficult for us to understand. So better to use only these notations. So follow these books only, because other books may use some different notations. Okay. So what is this proposition? This proposition is the proposition that is true when exactly one of P and Q is true, and otherwise it is false. That's mean if exactly one of P and Q is true, then the P exclusive or Q will be true, otherwise that will be false. So what will be the truth table? The truth table is now simple. The truth table for exclusive or of two propositions P and Q is, again, since we have only P and Q, so we need 4 row. Okay, so this is my P, this is my Q, this is P exclusive or Q. Now, if both is true, then that statement is false, because we define in this way that the proposition will be true if when exactly one of P and Q is true. Okay, so that's when if you have true and false, that is if P is true and Q is false, then exactly one is true. So therefore that is true. And if this is false, this is true, again exactly one of them is true. So therefore this is true. And if both are false, again by the definition this is false. Okay. Now this is exclusive OR. So again, as I told you, that is not very important. Now the most important logic operation is the conditional statement. So I know I am going very fast because that portion is very easy. Okay, you can find this is very easy. So that is the reason I am going very fast. So when it is come to the graph theory and combinatorics and even set theory, then I will go slowly. Okay, so what is the conditional statement? That is very important. It says that, so let again P and Q be two propositions. Okay, now the conditional statement we write it is P. We can write we arrow the P, that arrow, and then Q. Okay, so you can read as P implies Q, or if P then Q is the proposition. If P then Q. Okay. Now, what is the truth value of this conditional statement? So it is a conditional statement. Okay. Now, by the definition, the conditional statement is false if P is true and Q is false. Why? The conditional statement is P implies Q, right? If P, then Q. Now, suppose if P is true, okay, then you have a true statement. That's mean if P, and P is a true statement, then Q should be true. But here Q is false. So therefore, the conditional statement, this one, is false. Okay, and by the definition, it is true otherwise. So, okay. So first of all, I give, okay, then there is some name for this P and Q. Now here, the statement or the proposition P is called hypothesis. Okay. And the proposition Q is called the conclusion. Okay. And I write the truth table, then it will be clear to you. The truth table for the conditional statement of two propositions P and Q is, so again we have for row so this is P, this is Q, this is if P then Q or P implies Q. Now note that if this is P is true, Q is true, right? So if P then Q, then this statement is true because P and Q both are true. Okay. Now if P is true but Q is false, then the conditional statement if P then Q, that is false, right? Because your P is true, so that is happening, but Q is false, Q is not happening. So P implies Q is not true. So that is false. Now that is by the definition. So now if the given statement is already false, okay, right. So what is the statement? What is my P implies Q? It is if P then Q, right? So P implies Q. Now if P is already false, then whatever the value is Q, that statement is always true. That is P implies Q is true because you do not have any given condition, right? So output, whatever the output, that is true. So that's mean this is always true. Now if P is false, then P implies Q is always true. For an example, suppose you say that, so first of all, if you have a statement that say 1 plus 2 equal to say 4. So this is a statement, right? Now this proposition is false, right? Now similarly, if we have 2 plus 3 equal to 4, now again this is also false. Now if I say you that if 1 plus 2 equal to 4, then 2 plus 3 equal to 4. Now this combining statement is true. Why? Because what is given, that is already false. So therefore whatever the conclusion, your hypothesis is false. So what you are assuming, what is your hypothesis, that is false. So whatever the conclusion you have, so the whole total statement if P then Q, that is always true. Okay. So that is follows from the definition actually. Or if you feel that okay, no, this should not be the case, then you can assume this as a convention. So if the hypothesis is false, then whatever the conclusion is, the P implies Q is always true. Okay. Right. So since this is the first lecture, I don't want to go into more details because I think many of you are not attending this course today, right? Because they do not know we have a class. So I can stop the recording.